Okay, let's practice dilations on GeoGebra. Why don't we go ahead and turn the axes on and turn the grid on. And make yourself any polygon you want. And then set yourself a point at 0, 0. Let's just check to see the intersection x, y. Okay, that's where I want it. And let's use one of the transformations tool. We're going to dilate an object from a point by a factor. In order to see what command to give GeoGebra, just hover over the tool. Select the object to dilate, then the center point, and enter a factor, okay? So here's the object we're going to dilate, and we made this with the polygon tool, so it's an object. If you've just created points and connected them with segments, turn it into a polygon using the polygon tool before you try to dilate it. Dilate this object around this point, and let's double it. Oh, that was cool. Notice that my double landed on top of my pre-image. So my image landed on top of my pre-image. I'm going to add the point simply because I liked the way my original drawing looked a little like a Doberman Pinscher. Does it make sense that the point didn't dilate with the image? It was not part of the polygon, so it didn't go with the image. Now, I would like to add some illustrative points here, or rays here. Here's my center of dilation. Here's point A, and here's point A prime. Notice that they're on the same line. But I really want these kind of in the background, so let's change the color of these to something kind of light. And let's add some other rays from the center of dilation, H, which is at the origin in this case. Let's go through F and F prime. Let's change the color. Another ray through the center of dilation at the origin, through B and B prime, and I'm going to change the color, but let's get these other two rays in here also. And one more through E. And let's click on them all and get their color, more of a background color. Hey, I can do that without closing it. That's good to know. So notice that each point or vertex from the pre-image is on a line with both the center of dilation and the point on the image or the copy of the figure we have dilated. And let's go ahead and try another dilation. But let's use a factor that will make for a smaller image. Oh, I didn't tell it what figure. So here's my dilate. Let's dilate. Well, let's do something interesting first. Let's dilate this figure by a factor of 1/2 through this point. We should get an image that lands right on top of the first image, and we did. Now let's undo that just so we're not confusing the software, and let's dilate the pre-image. I want to dilate by a factor of 4. I'm not even sure the image will land on the page. Well, it landed partially on the page. Let's do one more thing. Let's dilate by a factor of 1/2. Good. Now, without a software tool or a rubber band tool or another kind of gimmick we've used in class, what tools could you use to prepare a dilation, and what is the difference between one and another? Let's just get 2 objects on the board. So what's the difference between this object and this object in terms of the point of origin? So from H to A on the smaller image, what is the relationship like from the second image? And does that relationship make sense? So let's get a measure on this distance from H to A. Let's use the show label tool, and let's get a measure on that label. So that has a distance of 1. And remember, that was the original image divided by 2. This was the original image doubled. So let's use a segment tool from H to A, and let's get a label that has a value. And what do you predict that's going to be? If this distance here was 1, what's the distance from the origin to the second point? And where did it go? I'm not finding it. So let's go back to Object Properties, Name and Value. It looks like I got the wrong property or the wrong object. Oh, here it is. N equals 4. What do you think? Does that make sense? That the distance from the origin to A prime is 4 times the distance from the origin to this copy's A prime. We had an original copy here, and we doubled it, and here it had a distance of 2 units. So is this going to be true for all the segments from one to the next? Is the distance from the dilation point going to be 1/4 in each example? Let's get some properties. Let's get a name and value. So that distance is 2. Let's check from B prime to B prime. And let's check the distance. We're expecting it to be 8 units away from the origin. We're expecting to have quadrupled the distance between the image that was halved and the image that was doubled. Let's see if it's true. Oh, I think I have a rounding issue here because look, it's 7 and we were expecting 8. That's making some sense. So I think it's under options. Rounding. Aha. This distance is really 1.12, and this is 4.47. And this distance is really 1.85, and this is 7.38. So let's find the ratio between those two. So go ahead and get a calculator out, and let's do that division. 7.39 divided by 1.85 is 3.9946. So that's quadrupled. We've got some rounding error on this tool. And 4.47 divided by 1.12, 3.9911. Again, that's quadrupled. We simply have a rounding error on this tool. So let's do one more. I think we've established a trend, but is it a reliable trend? Let's go to the top of the Doberman's ear here. Let's add a name and value. And we've got 3.44 popping up for that distance. And let's add another segment from the origin to the second ear. And let's get a name and value. And check that relationship. Is 13.75 4 times 3.44, or 3.99 times. So 13.75 divided by, get your calculator out, please. Yep, that's 3.99. So the distance from the point of origin from pre-image to image when doing a dilation is changed by a factor for every vertex on the original diagram. So I'd like you to go ahead and set up an image on GeoGebra that you can dilate. Add a center of dilation. Let's use the origin for this illustration. And add the lines that join the vertices of the pre-image to the vertices of the image.